Yes. So, welcome back. This is Lecture 4, still in Module 1. And we've kind of talked about things at the periphery, but this one we're really going to start doing some Python programming. Um, One thing that I would kind of encourage you as we go throughout really this whole course is just experiment with those different IDEs that were mentioned in the last lecture. Um, I'm going to kind of for a little while use command line and Notepad or Notepad++, which is a kind of free code-centric text editor. And then I will switch to idle and PyCharm. You don't have to use what I'm using, just uh, experiment, find what's going to make you productive. Okay, but what we're really going to focus on here is start with the basics. So we've looked at print statements, but kind of unpack a little bit more detail with that. We'll start to look at expressions. A lot of times those take the form of a math-like formula, but I'm going to try to tell you why not to think of them exactly as a math formula. We'll look at basic variables. They play a big role in programming. We'll look at the input function. Print's good for displaying information in a text-based environment. Input is for getting in information. And then we'll see what you need to often use type conversion functions to manipulate what you get into the type that you want it to be. And that'll round us out. So it's probably going to be a little bit longer lecture than the one that came before. Um, Try to keep it to about 15 minutes, but this one's got a lot of stuff in it. Let's jump in. So print statements are the way that you do output, especially in a text-based environment. Even if you do graduate to kind of more graphical environments. So Pygame we'll look at in a couple lectures. This still has a place. So it's a really good, simple debugger. So if you want to see what's going on at a certain point in your program, just print out the variables involved. Okay. Uh, so it's something that we'll use a lot. At some point, we will look at actual debuggers. So these are the tools built into your development environment if it has it. Idle has a crude debugger. PyCharm has a very, very sophisticated debugger, but it lets you step through line by line in your program, look at the state of your variables. It's kind of a critical way to diagnose problems in a like anything but a trivial program. Okay, but the print statement itself has this syntax that we've already seen. So with the word print, and it is case sensitive. Even if you're in a case insensitive operating system like Windows, Python plays by different rules. So it is very much case sensitive. So lowercase print, opening parenthesis, the stuff that you want to print, and then closing parentheses. And sometimes it's something simple like this. So this is just a string, got these quotation marks around it. Nothing inside of there is really going to be interpreted anyway. It's just should be output as is. As we get to more interesting things in Python, we'll see that there are often more than one piece that goes into breaking up or to building up those print statements. And anytime that happens, that you switch what type of thing that you want to output, you separate it by commas. So in this one, I've got my print statement, I've got quotation marks for a string, so the area of and then I've got just the number 3, the literal, that's called, also called an integer because it's a whole number. It's a different type of thing though than the string. So that's why I needed the comma to separate it, to break it up. And then I've got another string, the letter X. I've got a comma, another string. I didn't have to break these up, but it is allowable to break it up into 2 different strings. And then here I've got an expression. So this will compute the result of 3 times 4 or 12. And that'll be that part of the print statement. So let's actually test this. Always very important in programming to test things out, see that they really do what you think they do. So I'm going to close out of here. And I'm going to start Notepad++. Regular Notepad is fine here. You'll see though that Notepad++ tries to do color coding, so it will pick up that this is a Python script because I'm going to give it a py extension, and then it'll change the color on different things in my code. Just makes it easier to, at a glance, see what's going on. So if you'd like yours to look like mine, just go out and download Notepad++. Click through the installer. It's very easy. Okay. I am going to see it as on my other screen, but I just started up Notepad++, and then it brought me here. And let me type that command that we had on the slides. Try to get these side by side. Notice how the quotations are a bit different. This is one of my gripes with Microsoft Word, Microsoft PowerPoint, is they try to do these smart quotes. But if you were to copy paste that into a just regular text editor, it would error on those. So that's why I'm kind of retyping it myself down here. Okay, so that should be like the second print statement. Let me go ahead and throw in that first one as well. All right, so let me save this. File, save as. And I'm going out. We'll try to be consistent with my directories, my naming convention. So finding that work folder. And we're in module 1.4. Let me make a folder for it. And in there, we call this basic print.py. All right, so here you can see those syntax highlighting, color coding. Still absolutely just a text file, but like I said, Notepad++ picks up on the fact that this is probably a Python script, and these are probably special things that I'm taking advantage of, the print statement jam. Okay, so now I need to run that. And I'm going to stick with command line for a little while. Type cmd. If you remember from a couple lectures ago, we do cd to change working directories. So I'm here. I want to get to here. So I have to do ... go out to the containing folder. Now I'm on my root drive. And also remember that you can chain multiples of those together. So if I want to go 2026 summer, ETCS5021 examples. Gee, almost did that accidentally, but let me do it on purpose. Say you make a mistake. So I meant to go into 2026 summer, ETCS5021 examples, and then into module 0104. And that's where my basic print script is. So there's an error here. Okay, system can't find that. Instead of retyping the whole thing, you just hit the up arrow on your keyboard. It'll repeat the last command that you entered, and then you can just hit the left arrow key. Go in, find the part that you messed up on. So, put an X on there that I didn't mean to. So get rid of it. Don't need to move at the end. Just hit enter, and it'll run that command. So it's easy to edit the last command that you used. In fact, you can go more than that. If you keep hitting the up arrow, it'll just go further and further back into your history, or down arrow too. But now I'm in the right spot. Verify with the dir command. My basic print. script and to run. Python. I remember our trick two from 2 lectures ago. If you type a portion of what you want to type, either a directory name or a file like this, and hit the tab key, it will attempt to autocomplete. If it didn't get right, you keep hitting tab key until it does get it right. Okay, so hit enter, and there's your output. All right, but I want to point out a few interesting things here. Let me get my script up here, output down here. So, hello world, not much to that one, but down here, a couple interesting things happened. So yeah, each bit of this, so the area of the number 3, the x, 4 boxes, and 3 times 4. Each one of those parts is comma separated, but in the output, they've got a space between them. So the area of that was all within the quotes, but then right between there and the 3, the space was inserted by the comma in my print statement. One thing that Python doesn't do is it doesn't pay attention to what's called white space. This looks atrocious, but if I did this, something horrible like that, save it, and run it again. Let me tell you what I did there. I hit Control F to save, and now jumping out here, hit the up arrow to repeat my last command. Kind of gets me into a good workflow. So we can see the output's exactly the same as it was without that white space. So what you should do as a good Python programmer is be consistent. So for me, that means every time I put a comma, put a space after it. And if I have an operator, those in a second, like the star, just put spaces on either side of it. Makes it jump out to me. I can read code that's written that way. I don't personally like it, but some people are more compact and they want to do no white space whatsoever. So that type of programmer would prefer this. And I joke, but really, as long as you get into a consistent pattern and don't change in the same script, I think whatever you choose is fine. Okay. The spaces back in. All right, so that's the very basics of print. I'll come back in a minute and a few other things, the sep and the end argument, but let me go on to something a little bit more interesting. Okay, so next topic here is type. A little vocabulary here. I try to indicate vocabulary words with underline. I've got there in the slides. So Python uses implicit declarations, which is the opposite of explicit declarations. If your language were using explicit declarations, you would have to define any variable or value that you use and indicate the type. Not so in Python. It gets its value from just what you assign to it. So a lot of times where you see this first is in variables. And we'll talk more about those in a bit, but let me add a line to my code. All right, so that's declaring a variable called x. And because it's a whole number that I assign to x, Python thinks of this variable as an integer. Floating points are another type. So if I had 42.1, now it's still creating a variable x, but it's considered a floating point variable. Or if I do that, might seem like the same thing, but that actually makes Python think of this variable as a string. And depending on the type, going to be things will interface with that variable a little different. If we were just doing that, so x is 2.1, it at first doesn't seem like it really matters. If it's a float, if it's a string, I kind of get the same output. But where it starts to rear its head is if you attempt to do things with it. So try that line. Works fine. So x is 42.1, y is one higher than that, 43.1, works fine. But if you going back to this position, made x a string, now we get an error. And you're going to feel a lot of these as you do Python development, whether you like it or not. This is Python's way of saying that that thing that you just did, I don't understand. And it's giving you a couple clues. So some of these are better than others. Right now, it's kind of something to do with the type. We're talking about the type, so that makes sense. Just doesn't know how to take a string, which is what x is holding, and add 1 to it, an integer. Python's also telling you the line number. So it's in the script, that line. Let's go back and fix the problem. And it's maybe not entirely right in its error message. It says that the error is on line 5. That's where it manifested, but it was caused by what you did on line 3. All right, so type isn't important. And for now, those are the 3 that we'll need to worry about. As we get a little further into the course, we'll look at things like Boolean variables, sequences. We'll look at objects, dictionaries, sets, lots of other types of objects. But for now, we'll just stick with those. Okay. Um, Maybe one more little interesting tidbit before we go into something else. A note about strings. Maybe a couple notes. That's a string, which I'm printing out. Another way you can indicate strings is this. Languages, those mean something different, but Python is really just 2 different choices. And it seems crazy, but it gives you 2 other versions. So starting with 3 double quotes. You might ask, like, why all those different variants? I think what Python designers maybe were trying to solve is this problem. So I can look at that and know what the programmer probably intended. So they wanted to see the word hello, but with quotes around it in the actual output. But watch how when I try to run that causes problems. So it's telling me on line 12, that's the line we were on, that I forgot something. And Python's kind of sort of correct. I started a string, did some stuff, and it's not smart. It just sees that quotation mark there, thinks that we were ending the string, but we didn't really intend that. We meant to just display the quote mark itself. So by having these different types of delimiters, that's what these a fancy name for a character that starts and ends a string. Different types of delimiters, I can do this. I can start and end my string with single quotes, but now double quotes don't mean anything. Oops. Got to fix that here. Put it back to the float. Okay. So now we get I said hello with quote marks around it. Or if I wanted the other type of quote, just start with the delimiter that you don't want, and then you can use the other one inside. Okay, so I think that's why Python probably has different choices. Um, One thing that these triple quoted strings do that this type can't do is you can break it up into multiple lines. Like if you try to do a regular one, and I can kind of look at it and know what the programmer intended. But if you try to run that, here's the error that we get. Okay, so it sees the opening quote, but on the same line, it doesn't see the closing quote, so error. But a triple quoted string, on the other hand, is fine with those. Now you get first line, second line, you're allowed to do that. And that goes for both of these types. All right, so those are all interesting, but most languages do not have all those choices. What they do instead is they use what's called an escape sequence. Let me do start the I said hello. So up there that putting a quote mark here by itself causes problems, but if you do a slash, another slash and a quote, you just run it. Okay, so we got the quoted output, but still using the quote mark as a delimiter. So what's changed there is when Python's interpreting the string, sees the slash, it's like, okay, the next thing that comes after this is something special, it's an escape sequence. It looks at it and sees that it's a quote, and it's then realizes that we didn't mean to end the string, we just meant actually display a quote mark. Here's another one that's kind of problematic like that. If you did let's see if that works. ABC, a slash, and then DEF. Okay, like I said, didn't error, but let me change the letters. Let's do CTV. So why in the world did it put a bunch of like spaces there? This is called an escape sequence. The slash indicates an escape sequence, but the thing after it is really telling Python what type of escape sequence this is. So backslash and the T together mean put a tab, a couple spaces. But if that's not what you wanted, if you wanted to put an actual slash in the output, you do two together. The first one indicates an escape sequence. Second one indicates that this is actually a slash that they want to output. Okay. The other one that you might use from time to time, we kind of do something similar to this, but this time with an escape sequence. If I do first line, a backslash in, and then second line, I'll get two lines of output, but from just one print statement with some escape sequences in it. Okay. I don't know that we'll use that a ton, but it is kind of a cool trick to know about because this is the more typical way of solving these types of problems. Okay. Next on our to-do list is operators. And most of these are just the normal math symbol. So plus for addition, minus for subtraction, star for multiplication, and then a forward slash like this for division. We'll look at a few of those. Most of these tend to be what's called binary. And that doesn't mean binary as in the way computer memory, stuff like that is organized. This is binary as in there are two things involved. So you have A plus B. There's a thing on either side of the plus symbol. So the symbol is the operator, and then the things on either side are the operands. And so most of the time they are numbers, a lot of the time, but not always. And the type is important here too. Sometimes it makes a big difference if you get a float result versus an integer result. Let's try to illustrate some of those. So we'll do a couple examples of just math symbols, basic operations. If you're not familiar with this acronym PIMDOS, it's just the normal order of operations. So when you see a complex math expression, you evaluate the things in parentheses first, exponents next, multiplication after that, division after that, addition after that, subtraction, PIMDOS. So we'll look at that. And then we'll also look at a couple kind of Python unique ones, the star star, the percent, and these guys. Okay. Let me make a new script here. Sneakily bring in variables. That's one of my later topics, but I can start to cover it here. Let's start with that one. Script. Changing what I'm running. So let me do, I'm still in the proper working directory. Python, start to type the file name and hit tab. Okay, so X is 6. No surprise there. Jump to the PIMDOS. There's a reasonably complex one. So with PIMDOS, you do the things that are in parentheses will get evaluated first. So we're going to get 6 out of that. The star star means raise this to the power. We'll take 6, raise it to the 2 power, get 36. And I'm not good in math in my head. Whatever 36 times 4 is, get that next multiplication, and then add 3 to it. Beauty of writing a program, though, you don't have to do that math in your head. You just get the program to write it for you, to evaluate it for you. Okay, so 147 is obviously the answer. Um, Type is important here too. So my expressions so far have been using integers, but if you do any kind of division, two integers involved there, but we're not going to get an integer result. So z gave me 5.0. If I did that to a 5, 2.5. There is another like cousin of the division operator called like z2. So if you do 2 slashes, now if there's any fractional part, so I'll get 2.5, but the 0.5 is dropped, and it just gives you the whole number result. We'll see cases for both of those. Another kind of interesting one that might not be super self-explanatory is the modulo operator. So modulo is, I think a better name for it is the remainder. This is taking 10 divided by 3, but then giving you what the remainder of that division is. So it'd be 1. And for now, let me just make you aware that's a thing, but we'll look at some applications of that a little bit later. Um, Here's another interesting one. So, like I said, most of the operators work with numbers, but a few work with other types. Here's a really powerful one. If you take a string and multiply it by an integer, look at what it does. So it just repeats it that number of times. And you can get some crazy things in here. Like let's do arrow type shape and a backslash t. So that's a tab. Times that by 5. Actually, no, let me do a backslash n. So I was repeating the arrow shape followed by a new line 20 times, but this was a real quick and easy way to make 20 copies of that without any kind of loop, anything like that. Okay. I think the last one, quick before I move on, string concatenation. Just taking one string, like appending it to the other. Now S2, complete thing. So sometimes being able to build up a larger string from different pieces is really powerful. So that's at least a taste of operators. We go on to this print statement. We already talked about print, but now that we have a little bit more vocabulary, I can show you what the sep and the end arguments do. Just check onto what we've got. So print statement, commas by default are going to put a space between each of the pieces. So I'm not even going to really see that the commas are there. Run it. So I just see each piece. But sometimes you want to change that default behavior. So if I copy paste here, and this does have to come at the end. If you say sep equals, then you're telling Python for this print statement, what should the separator be? If you just wanted to repeat the default, you could do that. But you can do more interesting things. So if I do backslash n, now anywhere that it would have put a space, it's going to put a new line instead. Watch how this is different. That gives me these 4 lines of output. The end is kind of a little bit like that. Normal behavior with the print statement is after it's printed all of your stuff, it puts a new line in there. But if you don't want that to happen, do like a dash. You can't really see this until you do another print statement afterwards. Now it's going to produce one line of output, but on the first one, it's going to keep it kind of hanging. It'll put the dash, but then the print statement that comes after there, that just carries on with where the first one left off. Okay. a few little additional tidbits about print statements. Variables. Next thing. We kind of use them without making a big deal about it, but in Python and most programming languages, it's just some kind of symbol, X, Y, something more descriptive than that, that refers to a chunk of memory. That chunk of memory might be holding a number or a string. That's what my examples did. Or it might be something more interesting, like an image or a data file. While the program's running, that variable can change. So if you initially have n being stored in X, and then I add one to it, it'll now hold 11. Has a type associated with it. Kind of mentioned this already. A little bit unique to Python, that type can change. So if you were storing an integer in a variable, but then store a string in it, now it's a string variable, and that's okay. The one thing that I don't want you to think of in terms of a variable is don't think of it as a formula. And let me show you what I mean by that. Let's say we have a width and a height variable, integers. And maybe in my head, these reference like the square footage of a garden plot. So that's 20 feet wide, 30 feet long. When I do area equals width times height. So I'm going to get 600 out of that, 20 times 30. That's not the surprise. Area equals 600. If you thought of that line 30 as a formula that always holds, then if your garden plot got smaller, you might expect this to go to 300. But that's not what happens. Okay, still 600. And the reason kind of points out another like important takeaway from this example. All Python scripts, when you run them, they're going to go from top to bottom, do the things that you tell it to do in order. So I did all this silly print statement stuff from the start of our example. I created a variable called width, created a variable called height, created a variable called area by taking the current value of width and height, multiplying them together, print it out. On line 32, all I changed was width. Python doesn't try to like read your mind, do things that you maybe want it to do. It's not going to change area automatically for you. You have to do that yourself. If you want it to recompute, you do that. And now it'll be 300. Not a variable. Next important bit of Python, comments. And comments go by different names. They're an annotation, they're a note to self, note to other programmers. The thing that strikes people as odd is they don't affect in any way the output of the program. So the logical question that comes up from that is why even have them? Well, it's just documentation, explanation, things that accompany a code that make it more readable, that tell future you or some other developer, this is what I intended with this section of code. Okay, and Python only has one type of comment. So it starts with the hashtag. Everything to the end of that line is considered a comment. You can mix. So on this one, I've got some real code, and then I start a comment, which goes to the end of the line. Another kind of handy thing that you can do with those comments is if you want to keep a piece of code in there, but maybe not not evaluate it. So right here, I put a hashtag in front of those two because I'll see them. I haven't lost that bit of code, but when I run it, not going to have any effect. So now I just see the first and the last. I never changed width to 10, so it's still 600 in both. So unless you're sure you want to delete something, that's usually a less destructive way. It can also, like if you are working on code and something's broken at the moment, just comment it out and it'll keep it from running. But a good habit that I'm going to try to illustrate as we go is when you do start a script, try to indicate what it does. So we were trying to talk about operators in that one. I already kind of talked about this a bit, but errors are something that you will see a lot in your Python script. They indicate that something went wrong. You get this stack trace, so an indication of what was the error that you did. This one's a little bit more interesting because it has functions, something that we'll cover later in this course. But in that case, we had an error on a line of code, but we got to that line of code through another one. That's why there's kind of multiple lines. Usually you read these from bottom up. Well, there's the error. Here's the code that caused the error. Here's how we got to that point. Here's how we got to that point. So just read it from top to bottom. It's been a long lecture, but our last topic for the day is input statements. And one like easy way that you can use input statements is just to pause execution. Let me actually add that to the end of our script that we're working on. So if I put an input statement here, you don't really have a lot of control over this. The inner key is what signals that you're done doing input. So we're going to run, get to this point. It's going to display, press enter to continue on the screen. But then as soon as I do press the enter key, then I see this last bit of my program. Enter to continue. I do that, and then I see the last line. So sometimes I'll ask you just pause your script at the end with something like this. But that isn't actually the main purpose of this input function. The purpose of the input function is to get input from the user, and that thing is always a string. And if that's not what you want, you need to do a conversion function. And what I'm going to end this lecture with is we're going to write a pretty simple script that asks the user to type in to the diameter of a circle. We get that input from them, and then we do some calculations on it, and we'll print out the area of a circle. If you don't want to Google it, it's pi r squared. So pi times the radius squared to get the area of a circle. Okay, so let's do that now, and then we'll call it a day. Make a new script here. Put a comment. What we want to do, get the diameter of a circle and output the area. Save that. So visual thing that I like to do. When I'm asking the user for input in this way, I'll put a little colon in the space, just makes it pop a little bit, makes it apparent that they need to do something. And here it becomes a little different. So I want to um, store what they type into a variable called diameter. I'll actually do a little bit more with it, but let me do this first. So just echoing back out the diameter. All right, here, doing a new script. So I need to retype my command. Area calculator. Okay, so it's waiting. It's not just waiting for me to press enter. It's asking me to type something in and then hit enter. I'll do 20. All right, so I stored it, used it in my print statement, and it looks like things are okay. But where it breaks down a little bit here. So radius is half the diameter. But if I try to do math, this is not a number coming back, even though it looked like a number, 20. It's a string. So watch how we'll error right there on the division. So Python does not know how to divide a string by an integer. And this is our first occasion to use a conversion function. So the way this works is there are three of them: int, float, and str for string, and they indicate what type we're converting to. So diameter is a string, but if we want it to become an int, it'll look like that. All right, now an important thing to note here is diameter is still a string. It's just for the purposes of that expression, it's converted to an int. And then I do my thing. But if I were to try to do some math later on with diameter, it's not been permanently changed to a string. If I want, or to an integer. If I wanted that to happen, I could do this. In assignment statements, the right-hand side is always done first. So there I'm converting diameter to an int, just like in the line below. But what's changing is I'm like then overwriting it, replacing the string diameter with the integer. Just maybe make a note of that. For this, I think that's all I really need is I've computed the radius, and then I can do my thing with it. So I said pi r squared. Um, Pi is an interesting value for a lot of reasons, but from a computing perspective, it's a float, but it's a float that we can't store the infinite number of decimal places associated with pi. All we can do is just an approximation. So 3.1416. Okay. Or MDOS. Going to do the exponent first, then multiply by 3.1416. And I could throw in another little tidbit. That number is going to be kind of long, but if I wanted it to be rounded to one decimal place, I could use the round function. Computes this, feeds it to the round, but the round rounds to one decimal place. So I've got a print statement, a couple different pieces. So a string, still the string value that was inputted is, and then I should have my area rounded to one decimal place. Mean to make that? That was radius. 314.2, maybe add a little explanatory text. So since the diameter was in inches, that means the area is in square inches. Super important, but get an extra space in there. The area of a circle with diameter. Look better. And one thing that students seem to appreciate at this point is that in math, you kind of get used to just here's a problem, let's solve it for this particular configuration of values. But what we just wrote here, it's simple, but it's a tool to produce like all the answers. So they can type in any diameter, get an area of a circle out of it. And that's a cool thing. That's why programming is awesome. All right, long lecture. Quit there. Next lecture, we're going to look at importing in Python, and we'll look at a taste of Pygame. Okay.